Welcome back. Today I will implement real-life system of car using 16x1 mux, using minimized SOPs, and at last using decoder. So first of all, using 16x1 mux. Now for the Proteus implementation, first we will select all the required components. The first one is the logic probe to check if the output is high or low. And then the second one is logic toggle, which are the inputs. Now we have to give 4 inputs. So these are the 4 inputs, and these two are logic high and low. Now this is the IC40. Now this is the IC4067, which is basically a 16x1 mux. So we will use 2 mux for left and right indicator lights. First of all, we will give names to all the inputs. The first one is the left, and then so on. This is the left indicator and this is the right indicator. We won't use probes at the output, but basically we will use the blue LEDs. Now this was a small mistake because the fourth input, which is the blinking input, for this we have to give a sine wave or any input that changes value from 0 to 1 with a frequency of 1 Hz. Now we will short circuit all the output terms that are 1. Here you can see M3, 4, 5, 6 and 7 are 1, and then M9, 11, 13 and 15 are 1. So we will short circuit all of them. And then you will short circuit the remaining terms, which are 0, 2. Now these are the 4 switches A, B, C and D. But we will give them in the reverse order to the 16x1 mux. After this, we can see there is a bar on enable. So to enable it, we need to give the input 0 to it. Now here we have given 0 to all the terms that are 0 in the output. Now we will give the input 1 to all the outputs that are 1. Now we have turned on the LED and you can see it is blinking on 0 0 1 1. But here is a small mistake. We need to add a switch to this blinking input. For this we will first place a button, and then we will place a 10K resistor parallel to the input. Now our circuit for the left indicator is complete. Now we will simulate it and look at the results. 0 0 1 1 is making the LED to blink, and you can see it from the truth table too. Now for the second indicator light, that is the right one, the truth table is the same. So we will quickly give all the connections. And they both will work at the same time. And you can see both of them are blinking at the same time. So now we will verify some inputs. We are going to verify this 1 1 1 0, which will give us output 0 1 1 1 and then 0, and the output you can see is 0. Both the LEDs are off. So this verified our truth table. Now we will implement the same circuit using minimized SOPs, which are the sum of products. So first we will look at the truth table, and then we will make a Karnaugh map using all the values from the truth table. After making the Karnaugh map, we will make the equation of the function. For left and for right, the equation will be same because the truth tables are same. So after we made equation, we will move on to implementing it on Proteus. For implementing it on Proteus, we will require some gates: the NOT gate, AND gate, and OR gate. Now our circuit is complete. Now we will verify the truth table. So now all the input 0, the output is 0, which you can see the output is 0 in the truth table too. Now we will implement 0 0 1 1, which will give us output 1. 0 0 1 1 is giving us output 1, which is the LED blinking. So this verifies our truth table. Now we will implement the same circuit using a decoder. Now this is the truth table. for the left and right indicator, and here is the circuit for the decoder. Now as you can see, the outputs, on the outputs we have used NOT gate because the outputs are basically inverted outputs. So we have used NOT gates, and then we have used this 7 input NOR gate, and then another 2 input NOR gate, and then we did AND the outputs of both these NOR gates using the de Moivre's theorem. So now we will implement this equation 0 0 1 1, and now you can see the LED is blinking, which verifies our truth table. So this is all from today's video.